Good morning everyone, welcome to Competitive Education Center. Today we are going to cover the chapter Differentiation of class 12th. Here we are taking the reference of book RS Aggarwal so that we can easily get some examples and formulas from the chapters. So for differentiation chapter, we have also studied it in class 11th. So we might remember some of the formula, that is differentiation of x to the power n minus 1. That is x to the power n is equal to x to the power n minus 1. Then differentiation of sin x is cos x. Then differentiation of cos x is minus sin x. Then differentiation of tan x is sec square x. Differentiation of cot x is minus cosec square x. And differentiation of sec x is sec x tan x. Then the final trigonometric differentiation of cosec x is minus cosec x cot x. So these are basic formula which we are going to use in this chapter right now. Further formula I will discuss with you guys, but right now these are some important formulas, and hope this will help you to solve some questions and some examples. Some more formulas or some more rules I want to explain in front of you, that are when there are summation of two variable number, then how the differentiation is done. So basically when u plus v are a function, two different function, and now we are going to have differentiation of it, at that condition differentiation of u plus v will be equal to du by dx plus dv by dx. When that is in the subtraction form, then dy by dx is equal to in bracket u minus v is equal to du by dx minus dv by dx. Now when the two variable u and v is in multiplication form, then how differentiation will be done? That is given in third formula, that is u dot dv by dx plus v dot du by dx. Then now when these two variables are given in differentiation in divide form, then the formula will be v dot du by dx minus u dot dv by dx upon v square. So these are some basic formulas which will further come in use along with all other formula which we have studied earlier here. So now we will move towards another rule, that is called chain rule. If y is having a function of f of t, and where t is a function of g of x, then dy by dx will be dy by dt into dt by dx. So you can see here, you can cut dt, and the final answer will be dy by dx only. So basically when this is done to split the complicated equation and to solve it on a easy way. Similarly, this chain rule can also be extended with three different function, or assuming three different function from a big equation which is given to us. Like here on the second chain rule, we have been given that y is equal to f of t, where t is a function of g of u, where u is a function of h of x. So finally when we have to get dy by dx, then it will be like dy by dt into dt by du into du by dx. Ultimately it will give you like dy by dx. So let's go and solve some formulas, solve some examples with all using all this formula. So here as you can see that first we will take first example, that is sine x cube. Like here sine x cube is a function of y. So we assume that x cube is a t, because we have the formula of sine x but we don't have formula for sine x cube. So we will assume x cube as in t, then y will become sine t, and where t is x to the power 3. Then when we will differentiate y as the function is of t, so we will differentiate by dy by dt. So dy by dt will be equal to cos t. So and when we will then we have to also differentiate t with respect to x as it is a function of x. So dt by dx will be equal to 3x square. Here we have used the formula of d upon dx is equal to dy by dx is equal to n x to the power n minus 1. So this formula we have used, that is the first formula of differentiation, and this is used because for splitting the differential equation and solving it in a simple way. Now when we know the chain rule that dy by dx is equal to dy by dt into dt by dx, so we have got dy by dt and we have got dt by dx. So we will put this into equation 1. Okay, so this will help to get cos t dot 3x square, that will be ultimately give you 3 cos t, and where t is x cube, so we'll get 3x square cos x cube. So that will be our final answer. So as you see that final differentiation of dx dy by dx, that is y is equal to sine x cube, is 3x square cos x cube. So that is the final solution. So let's go to the second example and let's try to solve it. Like when it is given cos cube x, so y is equal to cos cube x. So we can write it in the bracket and cube in the outer portion, so that will be is equal to cos x whole cube. So let us assume that cos x is equal to t, because we know the formula of cos x, differentiation of cos x, not cos cube x. So we will make it in the form of t. We will assume as another function where y is equal to t to the power 3, where t is equal to cos x. So now when we will differentiate y with respect to t, then we will get 3t square. On the other side, when we will differentiate t with respect to x, then we will get dt by dx is equal to minus sin x. Then we will use the first chain rule, that is dy by dx is equal to dy by dt into dt by dx. Actually this chain rule is basically used to make a long equation into a small equation and multiplying them so that it get easily solved. So now from the first equation we have got dy by dt and dt by dx. So we will put in the second equation, that is chain rule, and we will get 3t square sine x, that is minus 3t square sine x. Now we'll put the value of t square. So from as we have assumed t is equal to cos x, so we will get minus 3 sin x cos square x. So this is the answer of differentiation of cos x cube is equal to minus 3 sin x cos square x. So how was it? Whether it is good or not? So let's take the third example, that is 10x. As we know, y is equal to 10x. We have a formula of differentiation of 10x, but we don't have formula of differentiation of tan root x. So this is the difficult portion which we have to solve. So for this only we will assume that root x is equal to t, root x, that is also is equal to x to the power 1 by 2, x to the power 1 by 2. So when it is taken, then the y will be equal to tan t, and t is root x. Then now when we will differentiate dy by d, when we will do differentiate y with respect to t, then we will get set square t. Differentiation of tan t is set square t. So we will get this, and when we will differentiate t with respect to x, so we will get 1 upon 2 x. Here we will use first formula, that is x to the power n minus 1. So that will be basically 1 by 2 into x to the power 1 by 2 minus 1. So we will get 1 upon 2 x to the power 1 minus 2. Then the final answer of differentiation of t will be 1 upon 2 root x. So hope you will understand what happened here. Then we will use first chain rule formula, that is dy by dx, that is equal to dy by dt into dt upon dx. So dy by dt, from here we have got set square t, and dt by dx we have got 1 upon 2 root x. So we will multiply it in this equation, and finally we will get set square x, as t is equal to root x. So set square root x upon 2 root x. So our final answer of differentiation of tan root x is equal to set square root x upon 2 root x. Hope you guys have understand this chain rule formula, first chain rule formula, and how we have used all the trigonometric formula here. Hope you have understand that. uh, Now we will move forward for using the second chain rule for chain rule, second part of chain rule, and other formulas of trigonometrics. And here this summation, here the we will also use this formula of sum, subtraction, multiplication, and divide form, which is available in the questions. So let's start and see some example of that. So for if you are finding it difficult, so please pause it and see what is actually given. This book has explained each and every example with all the step. So that's why I am creating this. Hope you will understand that. If you do not understand, please share and comment on mm, this video, so that I can help you, and I can make assure that your doubt is being cleared. So let's move with the second chain rule, and with summation and multiplication formulas in the differentiation. So here example is given for y is equal to y is equal to ax plus b to the power m. So let us assume that y is equal to ax to the power m. So now a plus b is equal to t. We have assumed that a plus b is equal to t, because we don't have any formula right now for differentiation of a plus b. So we have assumed it in the form of t, so that we can make it in the, we can fit in the chain rule formula. So y will be is equal to t to the power m. Then now we have assumed as a plus x ax plus b is equal to t. Now as we will differentiate y t to the power m, then dy by dt is equal to m minus 1, the same formula which we were using, that is n x to the power n minus 1. So this formula we have used here. Now t, basically t, when we differentiate with a function of sum, we will use that when we differentiate d upon dx of constant, so it give us 0. So when we will differentiate b, it will give us 0. Now it has only function with a. So when we will differentiate x to the power d upon dx, sorry, I will have to clear it. When we will differentiate d upon dx of ax, then we will get a x to the power n minus 1 upon, into n. So it will give us a x to the power 1 minus 1 into 1. So we will get only a x to the power 0, where x to the power 0 is equal to 1. So we will get only a. So hope you have understand this. And so I will further make you clear. So here we will also assume the chain rule, first chain rule, that is equal to that is equal to dy by dt. Dy by dx is equal to dy by dt into dt upon dx. So dy by dt we have got m t to the power m minus 1, where dt upon dx is equal to a. So we will get answer m into a into t to the power m minus 1. So our final answer will be m a inside bracket, that will be a x plus b, that is value which we have assumed as t, and the power will be m minus 1. So our final answer of differentiation of ax plus b to the power m is equal to ma into ax plus b to the power m minus 1. Hope you have understand these two formula. Let's see an example with numeric in a numeric form. So here we have given that y is equal to 2x plus 3. As you see, here is one having only one variable in the equation, that is x, and on the right hand side, so we will assume 2x plus 3 is equal to t, because we don't have any formula for that, and we will use a summation first formula, that is summation in this, so that we can solve it. So 2x plus 3 is equal to t, then when we then y is equal to t to the power 5, as the power is 5. So now t is equal to 2x plus 3. When we will differentiate y with respect to t, we will get 5t to the power 4. The first formula, n x to the power n minus 1. This formula we have used here. When we differentiate it, when we differentiate t with respect to x, as 3 is constant, as 3 is constant, we will get value is equal to 0. Now differentiation of 2x will be is equal to 2n x to the power n minus 1, where n is equal to 1. So 2 into 1 into x to the power 1 minus 1. So we will get 2 dot 0 2 dot 1. So our answer is 2. So what so we will get answer as 2. Wait a minute. So we will get answer as 2. Now we will use the chain rule formula. Dy by dx is equal to dy by dt into dt by dx. So when we will put dy by dt, that is equal to 5t to the power 4 into 2. So multiplying with this, we will get 10t to the power 4, where t to the power 4, where t is 2x plus 3. So our answer will be 10 t to the power 4, that is equal to 10 2x plus 3 ka power 4. As you see, we have just put the value of t here. So answer is 10 2x plus 3 to the power 4. So this is our final answer. Hope you have understand that. So now let's go for an equation third example. third example that is given here, y is equal to a x square plus 2bx plus c, and it is having a whole root square. So let us assume that t is equal to ax square plus 2bx plus c. Now when we assume this as a t, we will get y is equal to root t, means y is equal to t to the power 1 upon 2. So when we will differentiate dy by dt, we will get d by dt into t to the power 1 upon 2. So differentiating this, we will get 1 upon 2 into t to the power minus 1 upon 2 minus 1 upon 2. So this will give us 1 upon 2 root t. Hope you got the answer. So differentiation. So now differentiation of dy by dt is equal to 1 upon 2 t to the power of minus 1 upon 2, that is 2 to the 1 upon 2 root t. So differentiation, and now differentiation of t. So differentiation of t will be like 2a here, now 2a square. So here basically there is a square ax square plus 2b plus 2bx plus c. So now c differentiation of constant value is 0. So differentiation of x is equal to 1. So, and differentiation of x is equal to 2x. So you can see here ax square will give us 2ax plus 2bx will give us 2b, because differentiation of x is equal to 0, plus constant value, differentiation of constant value is 0. So finally we will get 2ax plus b. Hope you understand this when we differentiate dt by dx. Sorry, that is 2b. So we'll also take it like ax plus b, where 2 is out of bracket. So now we will put it in the chain formula. Now we will put it in the first chain rule, where dy by dx is equal to dy by dt into dt by dx. That is equal to, when we will put the formula, dy by dt is equal to 1 upon 2 root t, and dy by dx is equal to 2 ax plus b. Now this 2 and this 2 will cut, and we will get ax plus b upon root 2, root t, where root t is equal to where root t is equal to ax square plus 2bx plus c. So we'll, we will get ax plus b upon ax square plus 2bx plus c. So this will be the final answer. Hope you understand this. So this is the differentiation where one where the variables are given in the sum form. Now we will see when the variables or when the equation is given in multiplied form, and then how we are going to how we are going to differentiate it. Like here the first example, that is first question which is given in the form of multiplication is sine 3x dot cos 5x, and here we have to differentiate it with respect to x. Now here we have to assume that y is equal to sine 3x plus cos 5x. Now here we will multiply 2 and divide 2. Okay, so we will get a formula. So here we have made it in the form of formula, like let me show you here. This is in the form of formula 2 sine x into cos y. This is a formula. So now this will give us 2 sine x plus y, sorry, here it will give sine x plus y plus minus cos x minus y. Sorry, that will be in sine. That means 2 sine x dot cos y is equal to sine x plus y minus sine x minus y. So this formula we have used from class 10th trigonometric, or you can say from class 11 trigonometric. Hope you know all this, and if you don't know, then please refer to class 11th trigonometric formula where it is given. So here now we have now 2 cos 5x dot sine 3x. We will get 1 upon 2 bracket inside bracket, we will get sine 5x plus 3x minus sine 5x minus 3x. So further solving it, 5x plus 3x will become 8x, and 5x minus 3x will become 2x. So we will get 1 upon 2 sine 8x minus sine 2x. So that will, when 1 upon 2 will be multiplied with each, it will give us 1 upon 2 sine 8x minus 1 upon 2 sine 2x. So now we have got it in the form of subtraction. So this is in the form of subtraction formula. That is second formula which we have learned in first part here. So this is equation is in this form. So now we can easily sort out, or now we can easily solve it. So let's see how it is solved. So differentiate now this is, now it has two part, sin 8x and sin 2x is second part. So we will solve it in two different form with respect to x, as both are having same variable of x. So differentiation of 8x, so differentiation of 8x will be 8 cos x, because differentiation of sin x is equal to cos x. So here we will get 8 cos x, where differentiation of sin 2x will be cos 2x, that is 2 cos 2x. So these two and these two will be cancelled, then this 2 and this 8 will be changed to 4. So we will get 4 cos 8x minus cos 2x. So hope you have understand what formulas has been used. If you have not understand, please comment here, and if you have any doubt, I will surely sort it out for you guys. So please comment if you have any doubt, and further we will see it on next part, other how to use other formulas. Okay guys, thank you everyone, and good luck.